Very good morning. My name is Stuart Edmondson and I run the UK Electronic Skills Foundation, or UKSF. And what I'd like to do is to welcome you to this Girls into Electronics event on behalf of the UKSF, our sponsor Apple and our host university. In the next 10 minutes or so, I'd like to set the scene for the day and also give you a little bit of context. So I'm going to talk a little bit about our foundation, our work, and the opportunities that we can provide you. Also talk a little bit about electronics, and in particular about electronics in the UK and the career opportunities. So as I say, the UKSF is a charitable foundation. We've been around 12 years or so, and we work with a number of different universities, a whole range of different companies, and around 800 different schools. And our aim is to get more young people aware of, interested in, and pursuing careers in electronics and engineering. These Girls in Electronics events are hosted by 16 of our partner universities right across the UK this year. And the aim of the day is threefold. First of all, we want to explain a little bit more about what is electronics and semiconductors, so you've got more of an insight. We want to show you and have you experience what's it like to study at university, to see the facilities and the department, to meet the staff and students, and understand a little bit about the programs that you can potentially follow in electronics. Importantly, we want you to meet and engage with and learn from those that are working in the sector. So there'll be opportunities from female interns, people on work placements, and female graduates later in the day for you to engage with and hear their stories and learn from their experiences. Electronics is a hands-on activity, so there'll be a practical session later in the day when we use a microcontroller, an Arduino, as part of this session. The resource that you'll use, shown here on the screen, is yours to keep at the end of the session, and there's a whole lot of resources on our website for you to carry on and explore the microcontroller after the event. We ran these courses last year and they proved really successful, which is why we're doing the same this year. These are some comments that we received in the feedback, so we hope that you'll have a really good day too. I also wanted to share this feedback from a female engineer called Katie Jo, who came to one of our outreach events similar to this a few years ago. She then went on to study electronic engineering at Edinburgh University and joined our scholarship scheme sponsored by Selex, and she now works in the sector. So we hope today is the start of a journey from you that will see you go through university and become a graduate engineer in the electronics sector. Let me start with why. Why electronics? Well, I'll start by answering that question by offering a definition. Electronics is all about using technology creatively to develop innovative products to help solve problems and make people's lives better. The key words there are creativity, innovation and products. And you'll see later in the day, and it will be available online, we'll share with you later, a short video called Emma's Story from the Big Fix programme, which I think is a really great case study. And it shows about solving problems and making people's lives better, in this case Emma's life. So I want to take you back now to 2007, 16 years ago, when this man stood up with this device and as a world first. It is of course Steve Jobs, the then CEO of Apple, and that in his hand is the world's first iPhone, the world's first smartphone. Now in the 16 years since then, smartphones have become an integral part of all our lives. And I'm sure most, if not all of you, have got one on you at the moment. They're amazing technology. If you think about the communications, they have Bluetooth, they have Wi-Fi, and they have access to mobile phone networks, they have global positioning systems, touch screens, and they do facial recognition, which is really clever processing, very clever image processing associated with the camera, and at the heart of it is a processing unit that does controls all the processes, the logic, and does all the calculations. And that processor And in my model of an iPhone, and I've got an iPhone 12, it's called an A14. And within that processing unit, there are 11.8 billion transistors. Now, a transistor is a semiconductor device that can be used as a switch. It can either be on or off, high or low voltage, and therefore represent ones and zeros in binary. Fundamental semiconductor device. When integrated circuits, chips were first started back in the late 50s and 60s, there was maybe 4 or a dozen transistors in each semiconductor. But as I say, today, the processing unit that's in your iPhone or smartphone will have, in my case, 11.8 billion transistors or switches. And the size of that device is 88 millimeters square. So that means there's over 200 million transistors in each millimeter square, which is bewildering. But that's electronics, and that's the semiconductor industry. It is absolutely amazing. Let's look at the future. And commentators like Thomas Fry are saying that humanity will change more in the next 20 years than in the whole of history. It's a brave claim, and I guess if you're a futurist, that's the sort of thing that you are expected to say. But in recent months, we've seen the advent of generative AI, ChatGPT, which is clearly a big technology advance that is affecting what we do and how things are going to be in the future. One thing is certain, technology is the future, and technology depends on electronics and semiconductors. So be it virtual and augmented reality, drones, healthcare diagnostics and wearables, smart cities, the so-called Internet of Things, and particularly autonomous and self-driving vehicles. They all depend on electronics and semiconductors. And in the UK is a world leader in semiconductors and electronics. This is an infographic that's part of the resources that you'll get for today, with some facts about how big the sector is and the value to the UK economy. Also, demand for electronics graduates is high and the rewards are great. Here's some data produced at the end of 2021 from a recruitment company called IC Resources. And if you look on the left-hand side that I've circled in red, the graduate starting salary for people going into the semiconductor is more than £30,000 a year. So why choose electronics? There's a number of reasons. Electronics is the future. It's a sector driven by innovation and technological advances. The UK is a world leader, and there's actually a significant skill shortage. You would be in demand as electronics graduates. And importantly, you can make a real difference in helping solve the world's problems. There's great pay and opportunities, and there's really interesting work, as you'll hear from the people that you talk to later in the day. So if you do go to universities, as per this graphic here, we can help connect you with industry. So we partner with 28 different universities right across the whole of the United Kingdom, and their logos and names are shown on the left there. So if you study at one of those 28 universities, then you'll be eligible for several of our schemes. The first scheme that I want to tell you a little bit about, and again there'll be information that you get as part of your resource pack today, is called the Renaissance Award. Renaissance is a company that's based in several places across England and Scotland, and they are a chip design company. And they offer females starting in their first year a bursary of £1,500 and a paid work experience at the end of their first year. And you can apply for that when you're in year 13 and once you've got a place at one of our partner universities. More broadly, we run a scholarship scheme. This scholarship scheme gives you £1,000 for each year of study and paid work placements, either summer placements or 12-month placements at a partner company, as well as some professional and other development opportunities. We work with a whole range of companies to offer the work placements, and the names and logos are on the screen there. Some names and no logos you will recognise, of course, and others won't. And that's the nature of the electronic sector in the UK. We are a horizontal enabling sector with some fantastic companies that you probably haven't heard of. Our scheme's been running for 12 years. We've had over 750 people join our scheme, and importantly is a statistic there that more than 90% of them are working in the sector on graduation. So it's an opportunity. If you join our scheme, we know that it leads to really good employment in the sector. And later in the course, today, you'll hear from some people on our scholarship scheme or who've graduated from the scheme. There'll also be a video, and these four young female engineers are working in the sector and have all gone through our scheme, and this video will be available later. So thank you for your attention. I wish you a really good and successful day. Please engage, ask questions, and I hope you have a great time. And I wish you all